Hi everyone, in today's lesson we're going to talk about how to find limits algebraically that require the use of conjugates and common denominators. So we're going to solve the limit as x approaches 16 of this expression the same way that we normally would. We're going to try direct substitution and we're going to see what happens. So let's try plugging in 16 first. So we will get the square root of 16 minus 4 over 16 minus 16. So the denominator is 0, the square root of 16 is 4, so we still get 0 over 0. And this means that there's a hole at that value, which you can tell from the graph that I put there below. So we have a hole here at 16, and the question now is asking me to find the limit. And we can tell from this graph that the limit is approximately, 0.15 or something like that. So the only way that we can simplify this is not through factoring, because you can't factor anything like this, but we can use conjugates. Now you can either take the conjugate of the numerator or the denominator. So the radical is here, so let's just look here. We have radical x minus 4 over x minus 16. The conjugate of the numerator will be radical x plus 4. So we're going to take radical x plus 4 and multiply it by the top and bottom. So I'm going to go through the algebra. Radical x times radical x is radical x squared. And then we have radical x times 4 is a positive 4 radical x. Negative times radical x is a negative 4 radical x. And then negative 4 times 4 is positive 16. Excuse me, it should actually be negative 16. Okay, so now the trick for the denominator is we're actually not going to double distribute. We're just going to leave it as x minus 16 and radical x plus 4. And you'll see why in just a minute, why we're not going to double distribute the denominator. These two will cancel, and the square root of x squared is x. So we have x minus 16 over x minus 16 times the square root of x plus 4. Now what you should notice is that the x minus 16 and the x minus 16 are the same, so I can cancel them. So I'm just left with 1 over the square root of x plus 4. So you see how not factoring the denominator helped us. You know, we didn't factor the denominator, so we were able to cross out the x minus 16s. So now we can go ahead and plug our 16 back into the equation. So we have 1 over the square root of 16 plus 4, and the square root of 16 is 4, so 4 plus 4 is 8. So the limit is 1 over 8. Okay, let's move on to the second example. So now, same concept, I will plug in 1 and see what happens first. So let's try direct substitution. So we have 1 minus 1 over the square root of 1 plus 3 minus 2. 1 minus 1 is 0 over the square root of 4 minus 2. Square root of 4 is 2. 2 minus 2 is 0. So we get 0 over 0. So that means we're going to try to factor or use some sort of algebra to get us out of this. So it looks as though I have a radical in the denominator of a fraction, so I can actually use conjugates again. But this time I'm going to take the conjugate of the denominator. Okay, so what is the conjugate of radical x plus 3 minus 2? Nothing other than radical x plus 3 plus 2. Remember, with a conjugate, the only thing that you're changing is the middle sign between the radical and the number. Okay? So we're going to multiply this by radical x plus 3 plus 2. Okay? So, take a minute and double distribute the denominator only. Only you're going to double distribute this part, right? And then you're going to leave the numerator alone, and then hit resume when you're ready to see the answer. Okay, this is what I got. Okay, so I got 4, which is exactly what it should be here. The limit from the left equals the limit from the right, which is in fact 4. So the algebra, what I did was I double distributed the denominator and I got all of this. I realized that 2 radical x plus 3 and a negative 2 radical x plus 3 can cancel. And I left the numerator alone. I didn't double distribute that. And I combined the 3 and the negative 4, and I got negative 1. So these were able to cancel. And then all I was left with was this piece, and then I plugged in my x value of 1, and I simplified it to get 4. All right, let's move on to the next page. All right, example number 3 is just like all the rest. We want to try direct substitution first. So we're going to take the limit as x approaches 0. We're going to directly sub in 0 and see what happens. So I have 0 over 1/2 minus 1/2, which is 0 over 0. So this is a situation, again, where I have 0 over 0, and I'm not going to be able to factor, and there's no radicals, so I can't use conjugates. But what I can do is find a common denominator. So let's try to simplify this fraction first. So we have x over 1 over 2 plus x minus 1/2. So what I'm going to try to do first is make a common denominator for the pieces that I have here. So this side needs a 2 plus x. This side needs a 2 plus x. Whatever you do to the bottom, you have to do to the top. This piece needs a 2. And now let's simplify. So we have x over 2 over 2 times 2 plus x minus 1 times 2 plus x all over 2 times 2 plus x. So all I did here was just multiply these pieces and rewrite it. So now that I have a common denominator on the bottom, I could write it as one fraction. All right, I can distribute this negative 1. I can simplify. The 2 minus 2 cancels to 0. So I have x over negative x over 2 times 2 plus x. So if this is my fraction bar, I'm going to keep, change, flip. Whenever we divide fractions, right? We keep, we change, we flip. And I can cross off this x with this x. So I'm left with 2 divided by negative 1, which is a negative 2, times 2 plus x. And I can distribute, so I get negative 4 minus x. So now let's take the limit as x approaches 0. Let's sub in our 0 and see what happens. So what is negative 4 minus 0? Nothing other than negative 4. So let's check our graph, see if it works. The limit from the right is equal to the limit from the left, and it's at 4. So that's my limit. Excuse me, negative 4. All right, let's look at example number 4. Same type of problem. I want the limit as x approaches 0. We know by looking at the graph, the answer looks like it's negative 1, right here. But we're going to try direct substitution first. So we would try by plugging in 1 over 1 plus 0 over 0 minus 1 equals 1 over 1 minus 1 over 0, which is just 0 over 0. So in order to simplify this, we know factoring is out. We know conjugates are out because there's no radicals. But what we can do is try to simplify using common denominators. So this is our original, and we can technically write this 1 as 1 over 1. So all this would need would be a 1 plus x. Okay? So take a minute, see if you can solve this, and see if you can get your algebra to look the way it should so that you get a limit of negative 1. And then hit resume when you're ready for the answer. Okay, this is what I got. Okay, so this is my answer. I was able to get algebraically that the answer should be negative 1. So just to recap, I've made my common denominator. I distribute did the negative 1 in. I combined like terms. And then from this fraction, I changed, I flipped. And then here I just plugged in the value of 0. So the two main topics that we covered today were common denominators and using conjugates. Okay? So take a minute, jot down any questions that you might have, and we'll see you tomorrow in class.